Now we have determined our specific activity for replica 1 here, and we can do that also for the other two replicas, and the procedure is exactly the same. So we do these calculations, and for the different replicas we get probably different values. I have written it here as micromole per minute and milligram, just simply because it gives us nice large numbers and we don't have to work with these 0.2 millimole per minute and milligram, but it's just a matter of preference. So in order to do the calculations with the margin of error, etc., etc., what we need to do is we calculate the mean of the replicas, so that would be 262 plus 231 plus 245, and we divide that by 3, and if we do everything right, then we should get 246, and of course we still maintain this unit here, micromole per minute and milligram. The next thing that we do is we take the sample standard deviation, and just as a reminder, the sample standard deviation is given as the square root of basically the first replica value x1, and I call this here x1, minus the mean, that is this one here, we square it, plus the second replica minus the mean square, plus the third replica minus the mean squared. And now it is important that we recognize it is actually a standard deviation for a sample, and therefore we use n minus 1, and in this case n equals 3, so therefore this term becomes 2. And that's quite important, and some people missed out on that. So if we actually do this calculation, we will get a sample standard deviation of 15.52, and the unit of course is the same unit as we had originally here, namely micromole per minute and milligram. And the next step, we can calculate the standard error of the mean, and we know that the standard error of the mean, so SEM equals the sample standard deviation divided by square root n, and that is S over square root 3, and the S, that is basically the number that we just calculated. So if we put that in the calculator, we get 8.96, and the unit is still micromole per minute and milligram. And in the last step, we calculate the margin of error for this, and we know that the margin of error is defined as the t, the critical t value in this case, times the standard error of the mean, which we have calculated, and in this case we have the critical t value that was given as 4.3. And if we do this calculation, we get our margin of error of 38.54. So we can basically report back that our specific activity would be 246 plus minus 38.54, and the unit for this would be microgram per minute and milligram. Or if you prefer to have it as a milligram, then of course everything is divided by 1000 and it would be 0.246 plus minus 0.0385 milligram per minute and milligram of enzyme in this case. And I should say that this should read micromole, not, and here also micromole. It's not the grams. So I hope this makes sense, and this shows you how we can actually do the